Okay, so we're going to work on this general amplifier problem. And we're going to do this by looking at some data sheets to look at those. Okay, so first of all, we want to do the S120 speaker. So the S120 speaker, let's see, is right here. Okay, so you see that it has, right here is a spec that it says that it's 2.6 RMS or 5.2 peak. We're after the average power or the RMS power. And you see that it has an impedance of 4 ohms. So we just model the speaker as a 4 ohm resistor. So let's draw our speaker. So there is our 4 ohm speaker. Okay, so now we're going to connect it to a microphone. So here is our microphone. We're looking for some data. Here's all the pictures. Oh, here's the specifications. So it has a frequency range here. It has an output impedance of 300 ohms and a sensitivity of minus 56 dBV per PA, which is dB volts per Pascal. And 1 Pascal is 94 dB of sound pressure level. Okay, so they did all the hard part for us, and they said for a high, nice, loud sound speaking to the microphone, you get about 1.6 millivolts. So we're going to have a 1.6 AC signal with a 300 ohm Thevenin resistance. So we're going to come in here, 1.6 millivolts, and we have a 300 ohm series resistance. Here is our V out, and so we're going to get V out is just a voltage divider, 4 over 4 plus 300 times 1.6 times 10 to the minus 3. So that comes out to 21 microvolts. So then my power, since this is a amplitude, not an RMS, is going to be equal to 1/2 V naught squared over R, which is equal to 1/2 times 21 times 10 to the minus 6 squared over 4. So this has a power of 55 picowatts, which this has a peak of 2.6 watts. We're not even close. I'm not even sure you could even hear this. Okay, so now what we're going to do is we are going to use an amplifier. So there's this PreSonus microphone preamp that we're going to use. So let's go look at the data sheet for that now. So here is our amplifier. Oh, it looks nice and pretty, lots of control. We are just interested in the specs. Okay, so here is the frequency range. Here is our gain. So our gain is in dB. And then it has, we're looking for input impedance, output impedance, and gain. So here is our gain. Here is our input impedance, 1.3 kilo ohms. And then we got to look for an output impedance of 51 ohms. Okay, so now we go back to this, and we are going to get our amplifier. So we're going to start with our amplifier model. So it has an input impedance of 1300 ohms, and it had a gain. Well, let's go over here. And so our gain was in dB, and so then we're going to do maximum gain. So this is 10 to the 66 over 20, which is equal to 2,000 if we convert it into linear units from dB. So this is our V1, and this is 2,000 V1, and we have an output impedance of 51 ohms. So there is our amplifier. So now we're just going to connect our input signal on this end, and we're going to connect our output signal on this end, and then we are just going to calculate what our output is. So now VO is going to be able to start over. We get 1.6 times 10 to the minus 3 times, you see we have some loading here and we have some loading there. So this right here is a voltage divider, and this is a voltage divider. So we have an input side loading and output side loading. And then we have our gain, which is 2,000, and then we have our output side loading. And that equals our V out. So now we plug all these numbers in, and so this is equal to 1.6 times 10 to the minus 3 times 0.8125 times 2,000 times 0.0727. So what we see here is that this piece here is our biggest problem, right? Because we're losing about 0.2 on the loading, on the input loading, and then we're losing a whole bunch on the output loading. But, you know, we have what we have. So let's plug in all of our numbers. So we have V out equals 0.1891 volts. Well, that is way better than our 21 microvolts. So now we have our power is equal to 1/2 V naught squared over 4, which is equal to 1/2 0.1891 squared over 4, and so we have a power of 4.5 milliwatts. Well, way better than picowatts, but it's still not good enough. So what we're going to do is we need more gain, so we're just going to add in another amplifier. Now, we could have gotten a power amp instead of a preamp, but we're just going to cascade our amplifiers and throw another one on. So now what we're going to do is let's draw our amplifier. So our amplifier was 1,300 for my R in. We had a gain of 2,000, an output impedance of 51 ohms, and now I'm just going to connect this one to another amplifier. So those are my two amplifiers. And now we're going to take our two amplifiers and add those together with my input side and my load. So now I'm just going to cascade all of those together. So 1.6 times 10 to the minus 3. Input side loading, 1,300 over 1,600 times our gain times the amplifier to amplifier loading. times our gain times our output loading. And we get a V out of 364 volts, which is way more than we need. So how much do we need? So what we need is 2.6 watts, which is equal to 1/2 V0 squared over 4, which means we need a V0 equal to 4.56 volts. So what we're going to do is we are going to come in here and adjust the gain of our last stage to be what we need. So what we're going to do is we're going to go 4.56 is equal to 1.6 times 10 to the minus 3. Well, let's just grab all of this. Okay, and then we're going to come in here and replace the gain of this last stage with A. And in the V0, we're going to make this 4.56. And so we solve this equation and we get A equals 25.06 volts per volt, because it's input voltage and output voltage. We want to do this in dB, and so A equals 20 log 10 of 25.06, which gives us an A2 equal to 28 dB. And that is, so we have two amplifiers. The first one has a gain of 66 dB. The second one has a gain of 28 dB.